we're given a graph of a function and then asked to come up with a new graph for a transformed version of this function. So we're not working with one of our toolkit functions this time. All we know about our function is what's given in this original graph. So the first thing that we want to do is figure out what types of transformations have happened to this particular function. So we're looking at the new equation, y equals 2 times f of x minus 2 plus 1. So let's split these into two different categories, horizontal changes and vertical changes. So first let's think about the types of horizontal changes that have happened. Horizontal changes come from things that happen on the inside of the function. So here I'm looking at that minus 2 on the inside, and the inside always feels a little bit backwards. So having a minus 2 on the inside actually will shift our graph 2 units to the right. So a minus goes to the right, a plus would go to the left. So now let's look at what types of vertical changes have happened. Having the 2 out in front of our function, so things on the outside cause vertical changes, is going to give us a stretch by a factor of 2. And having the plus 1 at the end is going to go up 1 unit. It's our choice whether we do horizontal changes or vertical changes first, but we'll do all of one and then all of the other. And within the vertical changes, since we have a stretch and a shift, that stretch needs to happen before we do the shift. So the order within those vertical changes is important. Let's go ahead and just start with the horizontal changes. So what I'm going to do is I'm going to go ahead and sketch in a new graph that has completed all of my horizontal changes. So I'm going to picture kind of these key points on my graph and imagine taking each one of those points and moving it over 2 units to the right. So if I move 2 units to the right and 2 units to the right, 2 units to the right, we end up with this new graph that has the exact same shape as our original graph, but now it has been shifted over 2 units to the right. Now let's take this graph and apply the vertical stretch to it. So when you're doing a vertical stretch, we're going to multiply the y coordinate of each point times 2. So let's go through one point at a time and take a look at this. So if we start with that first point there at 0, 0, if you multiply the y coordinate of 0 by 2, you're still going to have that point 0, 0. If you take the next point at 1, negative 1, if you take the y coordinate of negative 1 and multiply by 2, negative 1 times 2 is now negative 2. 0 times 2 is still 0. 1 times 2 is 2, and 0 times 2 is still 0. So the red graph shows what we would have after doing our shift 2 units to the right. The green graph shows taking that shifted to the right graph and stretching it by a factor of 2. Now for our last transformation, each one of these points on the green graph needs to be moved up 1 unit. So this point at 0, 0 moves up 1 unit. At 1, negative 2 moves up 1 unit. Up 1 unit, 1 unit. So this blue graph would be our final answer for this function. It's been shifted to the right 2 units. It's been stretched vertically by a factor of 2 and then been shifted up 1 unit. We could have done the vertical stretch and the shifting up first and then taken that graph and shifted it to the right 2 units, and that would give us the same final answer as well.